So we took a look at those marine environments. Now let's look at continental environments. There's going to be a lot more continental environments than marine, because once you're in the marine, you're just out in the ocean. So for the continent, there's a lot more variability. So I'm just going to show you a few of our continental environments so you can kind of get the idea of what we're looking at. So one very common continental environment is going to be the fluvial environment. Fluvial just means river, right? It's a fancy word for river. So rivers, right, come in all different varieties, but the most important thing is that rivers move around. If you take a look at this picture here, you can see the river here is outlined in orange, and you can see that it's meandered, right, quite a bit over time. You can see old areas on this side and old areas on this side where the river has been over time. Now realize rivers move pretty fast, right? They're moving through a pretty quick plumbing system. So what we tend to find in the middle of our rivers are pretty thick deposits, or pretty big deposits of nice big grains. So those gravels that we talked about in the last chapter. And then what we see on the edges, right, is when our river floods, that flood doesn't move as fast as the river itself moves. So we tend to find smaller grain sediment. So floodplains tend to be made up of silt and clay, right? So if you remember back to the last chapter, we had 4 grain sizes, right? We had gravel, we had sand, we had silt, and we had clay. So what we tend to find in our rivers, like I said, is gravel in the actual river itself, sand and silt along the edges of the river, and then silt and clay on the floodplain. So we can actually find all 4 different grain sizes. So our fluvial environments are actually very, very complicated environments. We can also see these things called alluvial fans. Now, an alluvial fan is where we see sediment that's getting deposited at the base of our mountains. So what I want you to notice, right, is I'm going to highly exaggerate this. Let's say here we have a mountain, and water, right, rivers are going to run down the mountain, and of course they're carrying sediment, and then they're going to run this way. Well, the speed of my river changes. As I'm going down a mountain, the speed of the river increases. It's going fast. When it hits the edge of the mountain, right, the flat part of the continent, the speed of that river is going to slow down. So, when that river slows down, is it going to be able to carry as much sediment as it did before when it was moving fast? The answer is no, right? So a lot of sediment gets deposited right here, and that's what we call the alluvial fan. Here you can see the alluvial fan. We've got sediment working its way down, and it's making this nice big semicircular deposit there. An alluvial fan is actually really similar to a delta. It's just forming at the base of our mountains. Now we can also have lakes, which are called lacustrine. That's the fancy word, lacustrine environments. So lakes are pretty diverse environments. They can be small, they can be large, they can be deep, they can be shallow. And they're filled with all different kinds of sediment. And as we talk about our sedimentary rocks, right, lakes can themselves dry up, so they can be full of evaporites. Right, so lakes that can also be pretty complicated depending on the nature of the lake. We can also see glacial environments. Glacial environments, like we see in this picture, are made of ice. Now that ice, as you can also see in this picture, is not pretty, pristine ice, but that ice carries a lot of sediment with it. So as the ice moves over the surface of the continent, it's acting like sandpaper and physically picking up sediment and then training it in that ice and moving it down. So glaciers, and we're going to talk about this as we move through some of our chapters, glaciers actually have an immense amount of sediment with them. Another environment we can talk about is aeolian environments. Aeolian's just a fancy word for dune. So in this environment, water is not my transportation method, but wind is, right? So in a desert environment, my wind is moving the sediment. And aeolian environments have dunes, which are definitely asymmetrical, as you can see in this picture. We're going to talk about that later in this chapter, how these dunes actually form. Now, as we move from the continent out to the ocean, there's a wide range of environments that are called transitional environments. So they're not 100% continent and they're not 100% marine. They're somewhere in between the two. So one that is very near and dear to our hearts is the deltas. So the delta is a fan-shaped accumulation of sediment that forms at the edges of our rivers. And again, the reason is just very similar to what we saw with the alluvial fan. My river might be moving downwards, and let's say it's going to open up, right, into a big ocean. So my river, as it's flowing, is moving very fast. Now I want you to think about the Gulf of Mexico, or any ocean for that matter. Do oceans move very fast? Well, the answer is no, right? Oceans do not move very fast. So when this river hits the ocean, it slows down. So just like we saw with the alluvial fan, what happens is because it's slowing down, we're going to get a huge deposit of sediment. And that's what we call the delta. And as you can see for our area, we've actually built up along 6 deltas over the last about 5,000 years. And there's a video that I'm going to send out that I'd like you to watch with us that kind of talks about how our whole region was made. I'll post that up as well under the modules. Other transitional environments, the beach itself is pretty transitional, right? We've got continental sediment that's sitting right there by the edge of our ocean. Barrier islands, this is Dolphin Island. These are all transitional as well. Lagoons, a lagoon is the area that's actually technically right here. This is the protected water between the barrier island and the mainland, so that's protected water. So it's not quite ocean, not quite continent, right? Somewhere there in between the two. And then we can have tidal flats. Tidal flats are kind of my favorite here. But tidal flats are areas that's dominated by the tide, by high tide and low tide. If you've ever driven across the Bonnie Carré, you might notice that sometimes the water seems deeper than other times. That's because the Bonnie Carré is a tidal flat. Some areas, the tidal range is much higher. Like here, this is up in Normandy in France. At high tide, right here, this is Mont Saint-Michel. This is a church. And at high tide, you can see it is surrounded completely by water. This road here didn't exist originally when it was built. But at low tide, as you can see, well, now it's sitting out here in dry land. There's no water there at all. The ocean's actually way, way out there. So some areas have pretty high tidal ranges. But these areas are pretty important because of the organisms that live in the tidal flats. As you can imagine, a lot of organic material collects. So we tend to find lots and lots of organisms all throughout our tidal flats.